friends. This video is going to be about how we can use slope. So far we've been exploring what is the slope, how do we figure out how steep something is. But today we're going to start to figure out what we can use slope for. So what if we wanted to draw a picture of a line, right? Like what if we wanted to show what a line looked like, and we knew what the slope was, could we actually draw that line? And so that's what we're going to take a look at today. So the first thing that you need to know is in order to graph with a slope, you also have to have a point, right? So you've got to know, hey, where is this line going to go through anywhere? And so there's lots of different points that we could use, but as long as we have any point, that's where we're going to start with. And then we'll take a look at how we can use the slope from there. So if I look at this first example, I've got a point -2, 3. So the first thing I have to do is find this point on my coordinate plane. So I'm going to find my x is -2, my y is 3, so my point is going to go right here. And that's the point -2, 3. Now, how am I going to use this slope that's 1/2? So remember that the numerator is the rise, right? Or how the y changes. And the denominator is the run. So I'm going to build myself a slope triangle with the rise over the run. So from this point that I just graphed, I'm going to rise 1 square. And then I'm going to run, or I'm going to go over 2 squares. So 1, 2. When I've finished my triangle, I'm going to put the next dot. And then I'm going to do it again. I'm going to make another step. I'm going to rise, oops, wrong color. I'm going to rise 1 square. And I'm going to run 2 squares. And I'm going to put another dot. And then I'm going to go again. I'm going to rise 1 square. I'm going to run 2 squares. I'm going to put another dot. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And I'm going to go all the way until I've run out of room on this side of the graph. But how can I figure out where the line would go back the other way? Well, we're going to turn around, and instead of going up these stairs, I'm going to turn around and go down these stairs. So instead of going up 1 over 2, I'm now going to go down 1, backwards 2. Right? Because I'm turning around. I'm going down my stairs. I'm going down 1, backwards 2. Down 1, backwards 2. Another way to think of that is -1, -2. -1, -2. And the interesting thing about that is, remember that a negative divided by a negative is a positive. So this slope of +1/2, we could think of as +1/2, or we could think of as -1 over -2, because that's still, right, would simplify to +1/2. So you can go, this is an amazing fact, you might actually not know this, but you can go upstairs, I'm sure you knew that, but you can also turn around and go down them. I know, it's like genius. Okay. Anyway, so then we're just going to sketch our line through all these points. I'm going to try to line this up nicely. And notice that I've got 2 arrows on both ends of my line when I sketch it. Okay, you might want to use a ruler if you don't have a line tool on your paper that keeps it nice and straight. Okay, let's try another example over here. So here I've got a slope of -3, and I've got a point of 3, 4. So let's start with our point, and let's find the point 3, 4 on our graph. So we're going to go over 3, up 4, and drop our claw. So that's our point that we're interested in. Now, if my slope is -3, I need a denominator. Here I only have a numerator. So I could think of this as -3 over 1, right? So here my rise is -3 and my run is 1. So using this method, I'm going to start from the point I have, and I'm going to go down 3, 1, 2, 3, and I'm going to go over 1. And that's where my next point's going to go. And I'm going to do it again. I'm going to go down 3, 1, 2, 3, 1, 2, 3. Got to double check sometimes. And then I'm going to go over 1. I'm going to draw my next point. And I'm going to do it again. 1, 2, 3, and over 1. And I'm going to put my next point. Now I think I got the hang of it, so I'm going to try it without the triangles. 1, 2, 3 down over 1. 1, 2, well, I sort of ran out of space there, so I could either think that it's going to be sort of right off the graph there, or I don't have to put that last one there. But, so here I'm going down these pretty steep stairs, right? What would happen if I came back to my original point and turned around? That's right, we could go up the stairs too. So instead of going -3 over +1, I could go +3 over -1. So take a look there. That's going to be up 3, 1, 2, 3. And now I'm going to go in the negative, backwards 1 step. And I'm going to do it again. I'm going to go up 3. And I'm going to go -1, right? In the negative direction 1 step. And so all of those lines now are going to end up nicely lined up. And I'm going to bring my tool in here and line it up. Get it right along there, and it should go through everybody. And notice I've got arrows on both ends. And so that is my line. That's pretty cool, right? So I'm going to show you a couple of things that can happen, a couple of like twists, shall we say, that people will love to throw at you. So let's take a look at some twists. All right, so here's one where I've got my point. My point is at 5, -2. So 5, -2, I'm going to put my point. And my slope is 3 over 8. So I want to go rise 3, right? Rise 3 and run 8. So rise is 3 and run is 8. Okay, so from this point here, I'm going to rise 3, 1, 2, 3, and then I want to run 8. 1, 2, 3, 4, 5, uh-oh. I ran out of space, right? I need like 6, 7, 8. It's going to be sort of somewhere out here, but it's off the graph. So I can't go up the staircase, right? If I try to go up this staircase, I run out of graph. So could I, instead of going up the staircase, could I turn around and go backwards down the staircase? So if I were going to do that, instead of going +3, I would have to go, that's right, I'd have to go -3. Instead of going +8, I'd have to go -8. So I'm going to change this from positive divided by a positive, which gives me a positive, to a negative divided by a negative. So now let's see if we can count it out. So from here, if I'm going to go down 3, I'm going to go 1, 2, 3. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Look at that. There, I can find the next step. And then I'm going to do it again. I'm going to go, instead of going up 3, I'm going to go down 3. 1, 2, 3. And I'm going to go over 8. 1, 2, 3, 4, 5, 6, 7. Oh man, it runs out that way too. But fortunately, I have 2 points here, and 2 points is all I need to get this line drawn in between them. Line them up. Almost there. There you go. Okay. Another thing that I'd like to point out here is notice how I went down first before I went over here. If you want to think of it as if I'm turning around the stairs, if you want to think of it as I'm running -8, right? I'm going -1, 2, 3, 4, 5, 6, 7, 8. And then I'm rising down 3, 1, 2, 3. Notice that will get you to the same point. So there's a couple of different ways to think about it. The important thing to remember is that the rise, the vertical change, is always going to be on the top of the fraction, and the horizontal change will be on the bottom of the fraction. But it actually doesn't matter which one you count first. Okay? Let's try one more of these twist examples here. So here's another point. I've got the point 4, -8. So I'm going to put that point right there. And now this slope is -7. And remember, if it doesn't have a denominator, I've got to do -7/1. So the rise is -7. And the rise is -7. And the run is over 1. So we're going to count from our point down 7. Well, look, I can already see I can't count down 7. There's only 2 spaces down there. So instead of counting down 7, I'm going to have to count up 7. So 1, 2, 3, 4, 5, 6, 7. So now if I counted up 7, instead of running +1, I've got to go backwards, right? Because I went the opposite direction. So I have to go the opposite direction down here. So I have to go -1. Again, we're just changing that slope into +7 over -1, which is still a negative fraction, right? Positive divided by a negative is a negative, in the same way that a negative divided by a positive is a negative. Okay, so I went up 7, -1, and I'm going to put my next dot. I'm going to see if I can count that out again. Can I go up 7? 1, 2, 3, 4, 5, 6, 7. And then I'm going to go -1. And put another dot. And can I go up 7? 1, 2, 3, 4. I can't go up 7 again. So that's as many dots as I'm going to be able to get on my graph. So hopefully, well, fortunately, it's enough that I can take my ruler and line up my ruler in between these dots. And notice that I'm always dragging my line out to beyond the grid, right? Like if you've got graph paper, and so your graph paper goes on forever, just make sure that it goes out as long as usually like -10 to +10. And then you've got arrows on the end, because this pattern is going to keep going forever. Just because I ran out of graph paper doesn't mean that the pattern's going to change. This staircase will still be a really steep downward staircase, right? And it will go on forever and ever. Okay, so that's cool. So take a moment and do a little bit of practice with those so that you get to feel comfortable with how we use slope to graph a line. All right.